What's up, guys? Today I wanted to talk a little bit about recursion. If you're a beginner Python coder, you've probably heard the term recursion thrown around a lot. And the simplest definition is you're calling the function inside of the function. And that sounds a little complicated, but by the end of this quick video, you'll understand. So the most important part of recursion is the base case, which is when you can no longer use recursion. And that seems a little complicated. So here's an analogy. Imagine you're peeling back the layers of the onion in an onion, and eventually you're going to get to the core where you can't peel back any more layers, and that's the base case. Oftentimes when writing a recursive function, you want to start with the base case just for convenience. So for our recursive function example, let's do the factorial of a number, and I'll build two functions, one with recursion and one without. So starting with the one without recursion, let's define a function of factorial non-recursive. And this will obviously be without recursion. And its parameters will just be a variable called number, that will be an integer. Running, and let's add this variable running total. And let's have it equal 1. If it's equal to 0, you'll see why it's equal to 1 in a second. For x, and now let's add this little for loop. For x in range 1 to number plus 1. Obviously I'm doing plus 1 because the range ends a little short. And then running total is equal to running total times x. And basically, obviously what I'm doing is multiplying this running total by x over and over again until I reach number plus 1. That's a simple loop. If you don't understand that, then maybe this video is a little bit too advanced for you. I'll be uploading some other more simpler Python videos if you want to watch those. And then finally, print running total. Let's test this function. Pretty simple. Factorial, non-recursive, and let's say 6. I think 6 factorial is 720. Oh, down here. Okay. I'll just delete that out again, and that's 720. Perfect. Let's do 4. Let's do 1. That's perfect. So this is our non-recursive model, which in this case I think it actually is about the same in terms of efficiency compared to the recursive model, which I'm going to show you right now. Test. Okay. Now let's define our recursive function, factorial underscore recursive, and its input will be num, which will again be a number. And now our base case in this case, which is what I said earlier, that's what we want to build off of. Our base case would be if the number is 1 or 0, because 0 factorial is 0 and 1 factorial is 1. So let's do if num is equal to 0 or num is equal to 1, then just return the number. And then let's have an elif clause. Elif the number is less than 0, then return enter a positive number, you insubordinate buffoon. So this is obviously better code because it accounts for negative numbers. And now let's get to the actual recursive part. So in our else clause, we'll have this is the vast majority of cases. So return, and this is the recursion. So you're returning the number multiplied by factorial recursive, which is this function inside the function, and that's the actual recursion element of the number. And what we're doing is, imagine I asked you to get the factorial of 100, but I gave you the factorial of 99. You would just multiply the factorial of 99 by 100. Now if I asked you for the factorial of 99 but gave you 98, you can see how it goes all the way back to 1. And this is essentially what we're doing in code form. So now let's test this little function. Print factorial recursive of 6 again. I know that's 720. That is the problem. Oh, I understand. So what I did wrong was we actually have to do number minus 1 because that's what we're doing. Obviously, you need 99 factorial, but you need first to get 99. You're going back. So that's what the minus 1 is for. Now let's run this again. That's 720. Let's run 4. Let's run 0 to test the first if clause. And let's run negative 7,654 for the elif clause. Enter a positive number. So that's a little bit about recursion. If you want to try some recursive functions yourself, I would recommend a beginner problem would be find all even positive integers before certain numbers. Make a function and you enter a number and the code finds all positive even integers. Remember, always start from the base case. In this case, it would be 2 because that's the smallest positive even integer. Hope you enjoyed this video. If you did, make sure to like, subscribe, and comment your answer to this problem below. Thank you for watching.